Okay, I had a question on how to solve this problem, and this problem came out of Operations and Management by Stevenson, real good production operations textbook. And so I figured I'd show you real quick how to solve it. It's really not that hard. I took all this information. Basically, I hit this click here for the Excel data, and I was able to get this data. I didn't have to type it in. And basically, this is we're at year 9, and we have these numbers. And we want to forecast for 10, 11, 12, 13, 14. That's part A. We want to calculate the control limits, plus or minus 2s. And finally, after that forecast, we find out the next 5 years, this is what we actually got. And we want to compare what how our forecast did against our actual numbers, and if the forecast is performing adequately. So it says here to use the appropriate model to forecast, right? So you should always graph your data. So I'm going to highlight my data. I'm going to go insert scatter plot. And I can see that probably a linear model would probably be the best thing to fit into here. And I could click on one of these dots. And if I right click on it, well, let me do it again. Let me get the labels too so you can see the labels. If you highlight the year in sales and then go insert scatter plot, it actually gives you the sales. So this is the sales for each year. Year 1, 2, 3, all the way through year 9. And it looks like a line would fit that pretty good. So what I could do, I could click on one of these dots and right click and go add trend line. And I want a linear trend line because it looks like a line would fit pretty good, and actually gives you the line, the least squares line there. And I want to display the equation on chart. So I can see that this line is the best line that fits that data, right? So these are my actual points, and the line is the predicted points. So if I plug in 1, x is 1, that would crank out wherever this is at the line. 1 times that. If I right here, I plug in 7 for x, 7 times that plus that would give you that point on the line. Okay? And the vertical distance between the line, my forecast line, and my actual line, that's called the error, or the residual. So when you do linear regression, what it does, it squares all those vertical distances, because if you just added them all together, they would sum to 0, because you have some negative and some positive, and they add up to 0. But if you square them and you try to find the minimum of that, then that would give you the best line that fits that data. So that's why it's called sometimes least squared or linear regression. So anyway, we can actually do it real quickly by going equals slope, and then my known y's are my sales. All right, that's this axis, and my known x's is my year. So what year I want to know what my sales are. So my slope, let me go ahead and just put it over here, and I'll call this slope. And then we can put the y-intercept. Y-intercept, guess what? It's equal to intercept in Excel. Again, the known y's are my sales data, and so that's my dependent variable. My independent variable is my year. And you can see that's the same thing here, 4.25 and 34.6. It's just rounding it off, right? Let me put the formula in here. All right, so I like to do this vertically, so I'm going to take this, I'm going to highlight it, I'm going to go copy. I'm going to paste it down here, transpose, to flip it. So we have our sales, and then I'm not going to get rid of the 0, 0, 0. Doesn't really matter, the sales. And then, so then we can put in our forecast number here. And our forecast is going to be basically what we got using this equation, this y equals mx plus b. So I'm going to go equals, well, x is 1. Well, let's do m first. We'll do it in order here. versus M, which is this 4.252. I'm going to F4 that because I don't want to move. I don't want to move off that as I copy the formula down. I don't want it to go to here, to here, to here. And I'm going to take that times the number of years, which is like my X. Then I'm going to add my Y-intercept, and then also F4 that to make that an absolute reference. Then we get our forecast values. Okay. I'm going to put the formula in here. Okay. So if I click on it, if I click on this, it's always sticking on that. That's why I put those F4s. It's always pointing to that. All right. So I just use that formula right here and forecast the values. So these are the values. Like right here at this at 7, at year 7, that's the forecast value. The dot is the actual value. So you can see that the forecast value is higher than the actual. So there's an error. So we can calculate the error. And the error, it doesn't really matter which way it's going to be because we're gonna square it. So it's going to make them all positive. But we could say it's this minus this. And then if we add them all together, or if we copy it down, then we have our error. I'm going to move this aside for now. So let me put the formula there. So it's just the actual minus the forecast. Now if I sum these, they sum up to 0, right? Because some are positive or some are negative. That's the way that model works. It tries to end, so we have to do the error squared. And so that's going to be equal to that caret 2 to square it. Okay, so that's the error squared. Okay, the squared error. Sometimes that's called the. If you add them all together, let me move this over a little bit more. Let me put that here. If you add them all together, let me put the formula. I'm gonna give a little bit more room. Now, if we add them all together, that's called something called. Let me do it this way. Something called the sum of squared error, which is just going to be I hit auto sum. It adds them all together. So you try to minimize this. That line there. Minimized all the vertical, all those errors squared. You add them all together, the vertical distances, and minimize that, right? So that's the smallest sum of squared errors you can get by putting this line in there. So a lot of high-level math did that, but Excel did it for you real quickly. Okay, so now it says so we haven't farmed part A yet. We want to forecast the next 5 years. So I'm going to paste this in here, transposed. If I just scroll this down, that's all that is. That's my forecast, right? So if you look at the answer here, 77. Well, let's take it down to 2 places because that's what the answer is. So 77.1, 81.35, 85.61, 86. Now, why are ours off a little bit? Because I think ours are probably more exact. They might have a little bit of rounding error. So ours are taking out many decimal places. So anyway, so that's the answer to part A. So for part B, it wants the plus or minus 2s control limits, right? So for part B, so we already have the error. So now we can calculate something called the mean squared error. And the mean squared error is equal to this divided by. It's like the average, but you have to instead of dividing it by the number, you divide by n minus 1. So it'd be the count of all of these minus 1, which actually would be 8, right? Because we had 9. But we'll use the formula. So that's the mean squared error, and then we can calculate something called S. Small s, And that's going to equal to the square root of the mean squared error. And we calculate 2s is equal to that times 2. And the book takes it to 2 places, so we'll take it to 2 places. So that's the answer to the 2s control limit. So you can see there it's 2.96. Alright, so finally, so now we have the actual, now it says we have the actual numbers, and they gave us the actual numbers. When I clicked on the Excel data file, they gave me the actual numbers, which is right here. So now I find out, after the next 5 years, I find out that, let me put a line under here so we know that these are the numbers I forecast. These are my actual. So the error I'm going to get rid of this sum because you don't really need it. So the error is going to be, just copy that down, right? So you can see, well, you know what, instead of copying it down, Control Z. I don't want that line under each one. So my error can't be higher than 2.96, and you can see that these 2 years, the error is more than 2.96. You know, the difference between the actual sales and the forecast is greater than 2.96. So that means for part C, no, it's not adequate. So that's the answer. This was part B. Okay, so that's the answer to that. Hopefully that kind of made sense. There's other ways to get this this equation. You can do it the long way. Also, you can go under data. If you have the data analysis pack, you can do something called regression, which does a lot. But this probably is the simplest way to do this. Now, also there might be some templates that'll get you these numbers, but the templates, the Excel templates that the book provided, aren't going to do some of the things for you that I've done here. The Excel template will get you some of the. This is probably the best way to do this problem. All right, so hopefully that helped. My picture is going to appear up here. If you want to subscribe to my channel, click on the picture. Like the video if you like it. Give me any comments. And thanks for watching.